Page 378, lesson 6.3 is on solving systems of equations using elimination. So we're going to learn about another method. It's kind of like the idea with all of this, it's kind of like having different tools. Like when you're fixing something, you know, there's a time for using a wrench or a screwdriver or, you know, hammer. And so the more tools we have, then we can use the best tool for the given equation. So elimination method, there's a couple of things that we're going to look at with this. So one thing is, if you look at problem 1, they're saying what is the solution of this system and use elimination. Like I said, on your test, I'm not going to tell you what method to use. You just decide which one you think is the best. So if you look at the two equations that are given, the idea here is that, well, it's like what they have set up here with this addition and subtraction properties of equality. So if two things are equal and then two other things are equal, you know, if you add the left halves of your equations, then that's going to be equal to adding the right halves of your equations. So like the example they give, 5 plus 1 equals 6, 3 plus 4 equals 7. So then if you add the left side, 5 plus 1 plus 3 plus 4, that should be equal to 6 plus 7. And if you check it out, both of those are equal to 13. That's the idea of what we're doing when we work these problems out. So if you look at problem 1, conveniently the y terms are opposites of each other. And this is the idea behind the elimination method, is if you have, first of all, in this more simple example that we're going to start out with, if you have terms that are opposites of each other, if you just add the left halves of the equation, add the right halves of the equation, still keeps it balanced. That eliminates one of the variables, and then we can figure out what one of the variables is equal to. They put plus 0 here, you wouldn't really have to do that. And then if you divide by 8, you get x equals 1. So that's going to be the x value of where these lines would intersect if we would graph these lines. And then if we put a 1 in place of x, and you can put that into either equation. They chose the first equation, which I kind of like just because there's no negatives to deal with there if I'm given a choice. So they put a 1 in place of the x, and then they worked that out. They subtracted 2, and then they're kind of skipping some steps here, but subtracted 2 and then divided by 5, and then they got y equals 3. So that means the solution to this system of equations is 1, 3. If we graph these lines, they would intersect at 1, 3, or maybe there's some kind of real life meaning behind what x and y represent. But again, on this problem, this is the simplest of the problems types that we're going to look at. Okay, if you have opposites, go ahead and add those together, and that will eliminate that variable. Then you'll be able to figure out one of the variables, and then you can substitute to find the other one. So if you look at the got it 1, we're going to go ahead and just look at part B on this problem. So just for a little variety here, if you'll notice on part B, actually the x terms are opposites of each other. So it doesn't matter if it's y's or x's. If they're opposites, then we can get those to cancel. Okay, so we're just going to add these together. Like I said, if you have two things that are equal, two other things that are equal, you know, think of the scale, like, you know, if you have a double pan scale, you know, then if you add everything from the one side, then it's still going to be equal to adding everything on the other side. So when we add these together, the x terms are going to cancel. Watch your signs here. This is like negative 3y plus negative 4y. And you can write that off to the side if you want. That's going to be negative 7y. And then 9 plus 5 is 14. And then if we divide by negative 7, then we've got y equals negative 2. So y equals negative 2. Then from there, we need to figure out what x is equal to. So we can substitute that into either equation. I'm going to substitute it into the bottom equation because x has a positive coefficient there, since x is what I'm going to be dealing with. So negative 2 in place of the y. And then this would be like negative 4 times negative 2. Negative times negative would be a positive 8. And then they're adding, so we subtract. They're multiplying, so we divide. And we get x equals negative 1. And then taking that information together, then we know that our solution to this system of equations would be negative 1, negative 2. These don't all have to come out nicely like this. It's possible to have decimals or fractions in your answers. A lot of these, they are going to be nice to us, and they will come out evenly, but just so you know, it is possible to have answers that are not exact integers. So if we look at problem 2, we've got kind of a real life problem here. The theater club sells a total of 101 tickets to its first play. A student ticket costs $1. An adult ticket costs $2.50. Total ticket sales are $164. How many student tickets were sold? So kind of like we did in the last section, we're going to make this into a system of equations. So probably represent would be a good word to have here. Let A represent the number of adult tickets. Let S represent the number of student tickets sold. So two things. One thing is it says that there were they sold a total of 101 tickets. So we know that, first of all, the adult tickets plus the student tickets equals 101. So that's this equation. And then the other thing we can look at is the sales. The ticket sales, the adult tickets were $2.50 each, and the student tickets were $1 each. A little different than what the book did. If you wanted to, you could say $2.50 times A plus $1 times S equals 164. Just because it's money we're dealing with. You don't have to have that. What they had is fine. But just to make sure you understand, there's the $1 and the $2.50 is how they got this. They don't really show anything next to the S, so, I would probably put it 1 there at least. But anyway, so those are our two equations. This one I think is different than the last one, and I'm going to do this differently than what the book did. So the first thing when I'm doing these problems, normally what I'm going to do is write the equations next to each other. Going back to what we did in the last lesson, this wouldn't be too bad for substitution. We could pretty easily solve, like that first equation, we could easily solve it for A or S and substitute it in. In this case, what I'm noticing is that, I'm just going to go ahead and put 1s in front of these. I'm noticing that the S terms are exactly the same. They're both a plus 1S. Okay, and you might say, well, that's great. They're exactly the same. You were just talking about earlier, though, stuff had to be opposites for us to use elimination. And that's true. And that's what we're going to do. But I'm going to do it different than what the book did. So what I'm going to look at is that if I want these to be opposites with the S terms, what we could do to make them opposites would be multiply one of the equations by -1. So this first equation, if you multiply both sides by -1, then we're going to have -1a. I'm going to put -1.0a just because the other one's got a decimal. Minus 1s equals -101. So by doing that, now my s terms are going to cancel. And we've got 1.5a equals 63. They're multiplying, so we can divide by 1.5. And if you divide that out, you should get 42. Whoops, not 4.2, 42. And I know the book had the same thing, but it just doesn't really make sense to me what they're doing. They just have the equations and then they say, let's subtract the equations. But they never really change the signs. I would rather multiply by -1. I think if you have the actual signs there, rather than thinking about, oh, well, this says 2.5, but I'm subtracting, so it's really like a -2.5. That's too much thinking. Let's just multiply it by -1 so that they're opposites, and then we can add the equations together. Okay, so once we have that, we know a plus s equals 101. So we put the 42 in place of a, and then if you subtract, then you would get 59. The question was how many student tickets were sold. So this tells us that it should be 59 student tickets that were sold. This was multiple choice. It matches with one of the answers. That's always a good sign. And so C looks to be the answer. Now, like we've talked about before, if you have time, I would definitely check this with your equation for the cost. So if we say it was $2.50 for the adult tickets and we had 42 of those, it was $1 for the student tickets and we had 59 of those. Does that equal $164? Okay, and we could work this out. This is 59, and then this should be the remainder of that, so it should be 105 to make that equal to 164. The book talks about, and this is, not a bad strategy otherwise, especially if you didn't have quite as much time, they just did an estimate. They said, well, it's about 40 of these and about 60 of these. And so 40, if you did 250 times 40, and then that would be 100. And then plus $60 for the student tickets is 160. And that's really close to 164, so it should be good. So let's look at the got it 2. Washing 2 cars and 3 trucks takes 130 minutes. Washing 2 cars and 5 trucks takes 190 minutes. How long does it take to wash each type of vehicle? All right, so there's different ways we could do this. Since we're talking about system of equations, we're going to go ahead and do it that way. So, we could define our variables first. Let's see, represent the number of cars washed, and let T represent the number of trucks washed. Okay, C for cars, T for trucks. So the first equation, 2 cars plus 3 trucks equals 130 minutes. And then 2 cars plus 5 trucks equals 190 minutes. Similar to the problem we just looked at, if you look at these, the C terms, our car terms, are both the same. They both have a 2C. We want them to be opposites so that when we add, they cancel out. So one of these equations we want to multiply by -1. You can do either one, but the first equation's got smaller numbers. And so that's the one I'm going to multiply by -1, just because then I'm going to not have to deal with negatives so much when I work this out. So I'm multiplying by -1. I'm drawing my arrow so I can see a progression of what I'm doing here. This would be -2c minus 3t equals -130. And when we work this out, the c terms are going to cancel. 5t minus 3t is 2t. And then 190 minus 130 would be 60. They're multiplying, so we can divide by 2. So t equals 30, which means 30 minutes for a truck. It's asking how long it takes to wash each type of vehicle, so we have to find both of them for sure, which I would probably do anyway. Would be a good idea. Since I've got room over here, I'm going to go off that original equation. If you want to rewrite the original equation just so you don't get confused, you can do that. So t is 30. And now let's figure out the car time. So 2c equals 40. So c equals 20. So that means it should be that it takes 20 minutes to wash a car and 30 minutes to wash a truck. And like we've done before, if you have time, substitute that in and make sure it works. So like the first equation, we put in 20 minutes for the cars. We put in 30 minutes for the trucks. Does that equal 130? It's 40 plus 90. So that works. And then the other one, 20 for a car, 30 for a truck. Does that equal 190? So it's 40 plus 150. So that does equal 190. So that works also. So we know our answers are correct for this problem. So that gives you a little bit of an idea of solving systems using elimination. Again, this is just for if they're opposites, we add them together. If they're identical, multiply one of the equations by -1. We are going to learn some other methods in this lesson, but I will save that for another video. So that's all for now. Have a good day.